have to say that the Socrates in Canada was just 2 weeks ago, and it seems like a lifetime ago already because of all the things that have happened. I was actually quite happy to come home from Canada without any problems on the flight, and I'm keeping my fingers pressed for everyone else that you were able to get home in time for the lockdowns that are happening everywhere. I'm totally happy that, because for us from Europe, it was quite a big topic already when we were in Canada at the conference, and I'm quite happy that basically my request for let's keep this thing alive and keep the company going, the community going, even though the world's going to change, has taken its own life and given birth to some amazing events already. So really happy to be the first one here. I cooked up this presentation in less than 2 weeks. It's not rehearsed, I have to say this at first. So if it goes wrong, that's just because it's awesome and really, really fresh. So yeah, choking the monolith. Saying that title, probably this first image will come to mind. The Strangler Pattern, right? Homer Simpson choking the life out of his son for the why you little and everything. This is actually absolutely not what is meant, right? So get that picture back of where it came from. Keep it out of your head. It's not about choking people. It's not about being violent against anyone, even though legacy code can probably make us feel that way. But it's actually the Strangler Fig pattern now. And the Strangler Fig is this interesting plant. There's actually a couple of those, but this particular one grows in Australia, and it's basically a tree that grows on trees. So it'll start somewhere in the middle of its host tree, it'll grow roots, it'll get stronger, and eventually it'll take all the light and all the nutrients from the ground and all the water from its host, and the host tree dies. And that's where this whole thing comes from. It's a name coined by Martin Fowler in 2004, so it's been around for quite a while. And he used it to describe a technique to replace large legacy systems in an incremental way, so that you don't have to do the whole big bang, let's write it all again. It's not a services pattern. It's not a microservices pattern for sure. It's also not really a service-oriented architecture pattern, which had been around at that time. It's actually just about replacing legacy systems. So you could do this with monoliths. You could do this with local applications sharing the same GUI. There's lots of ways to implement this pattern. We're using it mainly to break up monoliths for microservices now, but it's actually more useful than that. It has a lot more to it. So when do we ever use it, right? What's the context? Let's pretend we have legacy systems, and legacy systems, we all know, are basically a pain to work with, right? That's what we as developers always think of legacy code. It's code inherited from someone else that we can't really change without breaking things. The official definition by Michael Feathers is one that I rather like, the code without tests. It's also not one that's completely sufficient for what legacy code means. Someone on Stack Overflow actually said that it's all code as soon as it's written. That actually makes sense, but it's also more than that, right? It's not just about code. It's about the things that the system does for us. It's code that works. It's code that usually has worked for a long time. And in some of the systems that I've seen, especially in financial institutions, it's code that's been around for 40 years and it's still running on the same mainframe that it's run on in the 1980s. So it's actually code that's really important. It's code that has a lot of knowledge about the business. It's code that's been used by millions of people, and it's code that earns a lot of money. And we forget that, right? So the code, yeah, that's important, but it's also the system that's there and that's served us for a long time. Now, just like this bridge, eventually there come reasons for it to be replaced, right? Even if it's great, at some point we have to think of building new bridges. And some of the reasons, they're plentiful. Might just be that the business has changed, and especially with the financial institutions that I talked about earlier, that's happening right now because the old ways no longer work. Everything is digital now. Economies have changed. It's lots more small scale, high volume. Cloud providers nowadays give us so much technical options that it just doesn't pay to have your own computer in the basement anymore. Also, we've banked on technology that doesn't work or it's outdated and people don't use anymore, such as Flash clients. I used to do a lot of Flash programming, so I actually suffered quite hard from that transition. Nowadays, even if you still have Flash clients, it's really hard to find people who actually know how to program that anymore. So if you want to introduce any changes, that's not easy. The tooling is outdated. Last Flash editors that I've seen were all a couple of years ago and very Eclipse-based, so it's not really state-of-the-art. And then some of the systems that we've built, you can actually buy nowadays, right? So you don't have to maintain your own code that does, for example, document management anymore, or financial transactions. All of that is available as a commodity. You can just use it as a service even. So there's lots of reasons for a system that has worked for a long time to be replaced, at least in part, right? And not the least of which is the one at the very bottom that we all know about. If it's festered and grown mold over time, then it eventually becomes unmaintainable, and introducing new features just takes forever and it's really expensive. So all of these, right? We have to rebuild and eventually replace our old stuff. Now, that is not a problem per se, but some of the things with replacing bridges are kind of the same as with replacing old systems. You really have to build a new one next to the old one, right? So in order for people to actually take the other way, you have to finish a complete bridge before you can replace the old. You also have to sort of make it work in parallel. So for a limited amount of time, you're building two bridges. You're maintaining the one that's in place. And if you want to actually fix something or maybe introduce new traffic signs at some point, you have to do that on both the old and the new. So while we're transitioning, really the old vital parts of the system are still running, whose original creators are no longer there. Maybe they've actually switched companies or died even. And you can't ask them about a lot of things. So, there's a lot of stuff that went into the design of the original thing for good reasons. And people made some mistakes and learned from them on the way there. We can't really ask anymore. The documentation is not really great. So we'll likely make the same mistakes again if we're building a new system from scratch. Also, that replacement's not going to be easy. It's going to take a long time. So proxy that will the gateway really that intercepts all the requests going into the old system. And then we can actually make them go to both the old and a partly new system. And we can decide which request goes where at any time that we want to by just changing the gateway settings. We can do that in Roger scale, and eventually the old system will go away. Now, this is obviously a distributed system pattern, but it could also be done for a single application, a monolith, right? So we have a GUI, and it connects to a big ball of mud. And then we can put a facade in place that can take all the requests from the GUI and forward them to the big ball of mud. And then we can start picking new components and having them run in parallel with the old system, transition to more of them, and eventually the big ball of mud goes away. This is one way to do it, so the request interception. The other way would be the event interception, which goes like this. So first you have the client connecting to the server. Then you put a message queue in place. And basically all the things that are happening internally in the application are triggered by an event and basically give you a result event back. Now then you can take those events and actually run new components that are triggered by the same kind of event And just by adding listeners or removing listeners, you can make sure that the old system's running or the new system's running. That again, at scale, and eventually all that's left to do is replace the part that actually takes the requests and creates the first initial event. I didn't make another one of those big ball of mud drawings, but obviously the same thing could be done within the same application. So instead of a message queue, you would be using an observer pattern at that place. But it's really the same thing. Now, if we do it this way and we replace our own old system this way, there's a couple of things that work much better than with the full-scale replacement. So basically, there's no downtime, right? We can switch really easily comparatively. So it's not just one release after 3 years of work. We can do it more frequently. Now, how often those releases can happen is usually very much related to how often you can actually release the old system. So there's really no telling. It could be some months. It could also be maybe once per week. So definitely you'll have feedback much sooner than after having the whole thing replaced. Definitely you'll get a return on your investment much sooner because you can actually put new functionality in place far sooner than what would be the first possible amount of time after replacing the whole system. And you get more fine-grained options. So basically, you don't have to replace the whole of it. You don't have to rewrite the whole of it. You can leave some things unchanged, or you can actually just decide to leave them out entirely if they're not being used in the old system. You can actually introduce new features, and that's a recommendation that some of the people who committed to the original pattern have made, is that you actually start out by introducing new functionality on top of your old system, instead of just replacing existing parts, because the business will much more like that. And then it gives you an incentive and trust to go ahead with the actual transformation of old code. Also, because you're sharing the data in other ways by creating your new set of data with new functionality separate from the old one, or by actually pumping it through the message queue and having data duplication in place, you can run some experiments. So you can try out new features and you can decide whether they're actually worth completing or pursuing more details on, or switch them back off without people noticing. So it's actually quite powerful for allowing you to grow the system in a more natural, more evolutionary sense of growth. Now, obviously, there's also some problems. Probably the old and the new will run in parallel, and they're going to run in parallel for a long time, because by just replacing parts and keeping others in place, you might just decide that the old system will stay around for another 10 years instead of just 3. That's, on the one hand, that's actually a good thing, because you can save the cost for implementing the same functionality again if it's not necessary, but also it incurs maintenance costs. So if there's updates and if there's transitions on data structures, and if there's things that apply to the business at a whole scale, you have to basically keep them both alive. To which all the other things applied that I said before. Like if there's no programmers that know about the old system anymore, then it's going to be a problem, even if it's just partly being used. Always in an enterprise company, there's also the political factors. Like the people who are putting the new system in place, they want the old system gone, because they also want the old people gone. And that may create some pressure that is outside of just the technical stuff. So maybe in some places and in some company context, it's actually a better idea to go the whole big bang way instead of doing the incremental stuff. Also, again, if you have to keep the data in sync with the old and the new system, some parts, especially when it's about things that have to do with permissions or security issues or anything that is sort of cross-cutting against over all the parts of the system, that might actually be quite difficult, at least for a limited amount of time. So some of the things that will help you on the way by giving you ideas of how to do this better are related patterns that give you maybe a little help here. The proxy and facade patterns I've already mentioned before. Those can actually be used in different places for different reasons. So it's not just going to be the gateway. It could be both the gateway and installing a proxy in front of your message bus and the ways that you actually send events for the event interception thing, which is the other pattern that's already been mentioned. And then there's another one that's mentioned in the original article by Martin Fowler. That's the asset capture pattern, which basically means the changes that you're going to introduce to your old system, you can group by a business entity, or as I would understand it, a domain object. So something that has a certain sense of meaning could maybe be grouped together as a single component and then extracted and replaced. So domain-driven design will help. It's not exactly what is meant in this pattern, but it's definitely something that goes well together. So yes, please do the things that actually help building better microservice systems also when you're doing the transitioning. Right. So now that we've talked about what the Strangler pattern is, let's talk about storage, right? Because truth, if it were easy to actually replace your monolith that way, then everybody would be doing it and it would just be not an issue at all, and we wouldn't be talking about it. So it's really actually not that easy, and it's always the same thing because the pattern works for monoliths that are already well structured and already very well modularized, or use at least the event subscription, the event listener patterns, so that you can actually take things out and replace them with other things without damaging the rest of the system. So if it's all that way, then yeah, do it, and it will take a couple of weeks and you're done. Now, in real life, it much more looks like this. Yeah, well, we're working with a ball of mud, and we're working with one that's probably made from dung, as this dung beetle is. So we're dealing with a lot of issues that kind of relate to that. The new stuff that we're putting in place has a lot more value to the business. So they're going to force us to keep doing that first. So replacing the old stuff actually becomes second issue right now. And it'll stay in place for a very long time. So we get all the problems from the old, along with the pressure of bringing in the new. And it takes a lot of focus and a lot of strength to keep going and gradually replacing that old stuff. Also, it's usually not easy to find a single person who's responsible for making all the hard decisions, like which part of the old system should we be transforming and which part should we just throw away, right? I can't answer that. I'm just the developer. So I need to find people who actually know the business of the old system. Now I'm getting a really bad echo on my audio. Thank you. Whoever switched that back off, that was helpful. So yeah, we have these problems. We have technical problems as well, of course. We don't usually have those well-defined interfaces in place. We have to put them in. The code has all the issues that come with bad design and festering of dependencies and using the false abstractions. So you change something in one place, it breaks in another, right? And putting an interface in is actually not that easy. The documentation is usually not there, or it's outdated. We don't have really an insight into why the decisions of the old systems were made, because we can't talk to the people who actually wrote it. Finding stuff in an old code base that's really big is also troublesome, right? If you're looking for the one place to make the change that you're going to make, but you have no idea where that is, that's actually something that's going to take you weeks. And if that happens a lot, then it starts becoming really tedious. We have misleading names in place. So people gave names to things that aren't really the thing that they're being named after. That's a thing that happens. But it might throw us off really badly, especially when it's in conjunction with badly implemented design patterns. I know of a particular case where somebody tried to use the visitor pattern, but it ended up being a God class that knew the entire system. So it did the thing that it was supposed to do in exactly the wrong way. So it didn't decouple, it actually coupled the entire system. And it was really, really hard to get rid of that, especially because in the beginning we thought, well, it says visitor, so it should be, usable, and it had an inheritance structure that kind of looked like the original thing. So these can be really, really problematic. Other things is like we have business logic everywhere. So some of it might be in the front end, some of it might be in the database. Stored procedures is a thing that can actually create a lot of problems because it usually doesn't have tests and little documentation. So if you got a lot of logic in your database, there was a time where people actually thought that was a good idea. That might be really hard to even recreate. Some of the times in some of the systems that I've worked in, really, there was no way of figuring out what happens. You just know that you have to put A in this field, and then at the other end of the system, like 3 systems removed, something will pop out and say 35. But you have no idea how that got there and how it was calculated and why it was calculated or who put it there and which trigger does what in the database. So that's a big problem, as are dirty hacks. So in one of the banks that I worked in a couple of years ago, basically all the custom functionality that they added to their SAP system was added on top of the database. So they didn't go through the actual API channels. They went directly to the Oracle database that was underneath. And they picked some tables and some fields and did stuff with that. And now SAP is being replaced by a new version, and lo and behold, they're not using Oracle databases anymore. So that creates a lot of problems, but also there's lots of vital business in these old components. So it's really, really not as simple as just picking a thing and putting it somewhere else. You have to know the whole infrastructure, and you also have to know where the data is stored that you might need in some cases. Now, obviously, these are all common for any legacy code system. This is not something that's completely unusual, but it will bite you when you're trying to apply the Strangler pattern, because nowadays that's not a problem. Right? We have to deal with all these same problems in order to make the other thing work. Now, some of the things that can actually be helpful in that is the patterns that do a lot of great things for working with code in general, and also with legacy code that some of the smarter people than me have cooked up in their lifetime. First off, the seam, which is a term created by Michael Feathers. That's basically the idea is you put a thing in place that allows you to change the behavior of the system without having to change the system in that place. Now, that's a mouthful, but what it actually means is find some way of encapsulating the thing that you want to change, and then have a way of replacing that encapsulated thing by something else using dependency injection, using configuration files, using feature toggles, whichever way actually works to make the old and the new go side by side, or having a small and isolated part that you can test and modify. Also, it's a good idea to apply the walking skeleton, even though we're not really creating a system, but finding a business case that we want to replace that touches all the vital parts of the old system so that we can eliminate all the risk, and then you'll have a thing that you can actually easily replace. And then last but not least, the branch by extraction pattern, that's actually a pattern of how do you do the source code versioning. how can you do any kind of continuous delivery while doing these large-scale changes, even with an old system? Basically, that's sort of a combination of the things that I mentioned before. Put an abstraction in place and then have both the old version of the abstraction and the new version of the abstraction in parallel, and use feature toggles to switch between them so you can stay on the main branch. But these are all really helpful to get where you want to go. Now, if you've read the description of my talk, I promised you this thing. I've actually decided against really producing it. So there's a real life application that I was going to show and that I've already spent half a week setting up so it can actually run on my system. But I feel like it would be a bad idea to bash on people. So I decided to replace it with a fictitious system. It is modeled after something that exists in real life. And the problems that I'm going to tell you about are real problems that I've encountered. But it's not the actual thing. And I'm really not trying to hurt anyone. So SumCMS is a system that was sort of grown hysterically, as I say, in the 1990s. So it's been around for much longer than most of us. And it's also created a lot of money for at least one company, and probably also for the people that are using it. And it uses a MySQL database and Gradle for the build. By the time I worked with it, it used Ant, so that was interesting. If anybody remembers Ant, it's kind of like a Maven, but more painful. So this is a content management system. It has editing capabilities, so you can, all the things with drag and drop stuff on your pages, edit the text in place, publish, have versions of your documents and everything. Its template format uses Java server pages out of all things. That creates some problems that I'm going to come back to later. It has a virtual file system that basically means you upload a JSP page to the system, and it will store it inside of the database. And it also stores some metadata that goes on top of what you'd usually have in a file system. And basically, publishing means taking it from one database and transferring it into another one, or rather in another table. So it has a lot of text data in storage in the database, and it needs to sort of render those to actually display a page. So the thing with Java server pages is you need a Java compiler, even if it's a just-in-time compiler, to actually show the content. So that goes on top of the usual templating where you replace text. Right? It has active components, and it uses Java code to extend the tag libraries. I'm just explaining that because I know that Java server pages haven't really been used for 10 years. So if you haven't heard of it, those are all reasons not to use Java server pages. So there's also a module expansion system to the thing. So you can actually create your own plugins, which comes with an interesting baggage, but I'll also tell you about that a few pages on. And there's a mono repo that contains all of the GUI and the different parts of the thing, the file system stuff and everything. It has a single build made in Gradle that runs about 25 minutes on my very new MacBook Pro machine at home, out of which 23 minutes is just running the test suite. And the test suite is a number of tests that are set up like unit tests and use JUnit, but they're not. They're integrated tests. They use basically the entire system. So there's a running instance of the CMS, even if it's not the full thing, but at least the core of it that's injected into those test cases. And you can't really run any of those tests by themselves. You have to run the whole test suite at once so that it actually runs. So any kind of feedback from your tests will take about 23 minutes. I actually I downloaded the thing last week and I tried to set it up, and it took me about a day to fix the broken tests that were in there. Now, the problem that is the same with the full system is it needs a running instance of the CMS to do anything. So you can't really test things in isolation or transform things in isolation. It has no API that you could use. There's a shell, a self-defined shell that you can use from Java code. But it's not really something that you want to use in the way that we would use a REST API, where you could actually put a gateway in front of. You'd have to hand roll all of that and trigger the shell functionality to make that work. Now, the problem is in the code, in the classes that the system uses, there's a lot of mixing technologies and languages. So you get a lot of functions that return strings that contain HTML or JavaScript output. And it's really hard to figure out which code runs where at which time. The whole deciding where things go when you have a request that comes to the system and which page should be displayed is used by filtering directly on the HTTP request and response. So it doesn't use any of the existing frameworks and libraries that make you handle that in a more elegant way. It's all self-rolled. The method names, most of them aren't really telling you anything. It just said, lots of words like export or process requests or wrap or render, even all of the things that you would expect anywhere, but it doesn't really tell you which part of the business is being used right now. On top of that, it does its own threading. At least there's some events. And there's a couple of more things. I'll just skip across those because I see that I'm almost running out of time. So I've described a lot of problems that you've all probably seen in some cases. Now, what the hell would we do to actually refactor this thing with the Strangler Pattern? And the reason why I picked the system is because it shows you that there's a lot of problems that are not in the original description. And a lot of those problems are an actual issue if this is your product and if you're selling it and people are depending on it, then like it's installed on, let's say, 1,000 different machines for 1,000 companies that are all using this to have a running business. And now you're going to take it all away, or you're going to replace it with something that's not going to work for 3 years. That's bad. So how could we do this, right? So one of the ideas that I had when I looked across it was the publishing is a batch process, right? So it takes all the stuff that's in these JSP pages that are stored in the database, and it pushes all of that to another database, and then the rendering is taking place at runtime. So if you call a page, then it will be that takes care of the traffic. So while we're refactoring the CMS itself, the page could be running. The web page that we've created with the CMS could be operational, and it could do business. So that would actually take some of the pressure off, right? So for all of our clients that are working with this and are running their actual business on it, that would take some of the edge off. Even if the CMS part has some issues and goes down eventually, my business still works. Also, I can actually write my own HTTP filter to do the request interception. It's probably a bit more tedious because I don't really have a naming scheme that I can attach to, but I could use the same mechanism that they use to make it work for me. And basically just forward any request that comes in and it can't be handled by the old system, or maybe just copy that. Also, some of the stuff that's in the system could probably be extracted in the same way that it exists right now. So I could just take the original code, put it behind some web interface, and if it's still using the same database schema, then I could have the synchronization or the parts that are needed for the entangled mess to keep working together a bit more separated and a bit less hard to maintain and have long-running tests on, right? So probably the first step would be take out some of the parts of the original system make it run as its own service, and then start to figure out ways of disentangling the dependencies and taking care of the database problems and all of the stuff that comes on top of it. But then I'd have a build pipeline that runs maybe only 3 minutes and not 25. A thing that is actually a problem is handling anything that's regarding user management, right? So because the system does it by itself and it has its own database for handling permissions and all of that, I might need to have some intermediate steps to remove that and replace it with something that's widely used. So web tokens come to mind, obviously. But I'm not going to be sugarcoating this. This is going to take a long time, and it's actually going to be really, really problematic because it's everywhere. And then in the end, if there's any ways of actually making those tests run in a singular way and not just with the whole test suite, that would make a lot of the problems go away, or at least be less of a problem because it doesn't take as much time. Like I said, I spent about 3 days last week trying to set this up in a way that would work for a code demonstration or an actual coding exercise. But it just takes forever to get feedback, and that kills the whole fun of working with that code. It gives you so much. I mean, this is also true for legacy code in any case. It gives you so much to play with, but playing with it is actually no fun if you have to wait for 20 minutes. So these are the things that I found that I would be starting this thing with. A transition would probably take years. And no kidding, I can totally see why they haven't done it. It's always, do I really want to kind of spend all of my time fixing the problems that I should have fixed 10 years ago, or should I just build a new product? In the end, when you have something as bad as this, that is an option. And that would be the end of my talk, because that's when the Strangler pattern just doesn't fit anymore.